Okay, yeah, I just got the.
Okay, so this talk is going to be about the test harness as it stands right now. And I'm going to start by sharing my screen. Share screen. Okay. Cool. So the test harness, as we have it, is made in Foundry and is a variation of the unit tests that we already have in Foundry. And it is quite simple in that it just uses some environment variables. It reads some environment variables to know whether it needs to fork a given network and whether it needs to execute the unit tests on a set of contracts that we will deploy, or execute the unit tests on a series of contracts that we will read from the network that we have forked. That's it. We use this new env or cheat or function in Foundry that allows you to read variables. This will read the network environment variable, and if it doesn't find it, it will assign to network this thing. I have to see what this network localhost mock thing, time log things. I have my test constants. A definition from for time constants. There are utils here. So here I have defined what all these constants are so that I don't make typing mistakes. So I have variables that are localhost mainnet and internally mock network, the strings that I'm going to be comparing. And in text extensions, I have a function that compares to strings. That's it. So when I go to flash join, I'm basically going to say the environment network, the environment variable called network, is it present? Yes, if it's present, it might be present because it's, for example, set here in a shell script. This is actually how you kick the test harness. You will say, okay, I'm going to export these environment variables that then the test harness join this all is going to read. Okay, and if it doesn't find them because you are not executing the test harness, but you are instead just doing forge test like down here, then this will say, okay, I don't have a network variable. I'm going to assume that this is localhost, and I'm going to do a fork of localhost. When I do a fork of localhost, it's funny, when you tell it to do a fork of localhost, it works. It just creates a new node, I think, which is quite funny.
And you're not pinning it to a block.
No, I'm not pinning it to a block yet because I don't know. I didn't need for this one. The test harness itself, you shouldn't pin it to a block because then is the test harness. The idea of the test harness is to do these tests now in whatever there is in in the network, in the state that it is. That's the idea of the test harness. However, we have here the two options: setup harness or setup mock. Okay, when you do a setup mock, is because you are going to run the traditional unit tests. Okay, the traditional unit tests, they could still be in a fork of mainnet, and you can pin them to a block because it's like, okay, I'm going to make this ideal environment in which I run the unit tests, which are the traditional unit tests. It could be a fresh network where you deploy all the contracts, or it could be a fork of a network where some contracts are deployed and you deploy others. But it's an ideal environment. That's where you run the unit tests. The harness, on the other hand, is this block in the network. I don't manipulate anything. I'm running the tests here. With that idea,
say for something like the Phi tokens or the pools, which are constantly updated contracts or constantly iterated contracts.
Yeah.
We might have one set that works on a certain series, and that would be the mock. And then we would have the harness, which always works on the current ones.
It's kind of that.
Although
Let
every
me show
time
you how,
we
let me show you how it works, because this test actually does that. It does either create its own joins, that does it ideally, or reads them from the network, which I think is where you were going at, right?
yes.
Okay, cool. So look, when you are making your own ideal environment, you are actually going to deploy your mock tokens here, as we would do normally in unit tests, and you are going to deploy your new join in here that you're going to test, and you permission everything so that the unit tests work. Okay, so if I go down here and I do the test, join TSO, it's going to do exactly that. It's going to come here to the setup mock, and it's going to create an ideal environment, and it's going to run it. What if I want to run the test harness? The test harness is a little bit different. When you go to the test harness, I'm actually going to read the actual address for the ladle for my network. See, if I go to my test constants that I have somewhere here, here, test constants, in the constructor, I'm actually loading addresses for each network in this mapping, so I know what they are. When I come to the setting up the harness, it's like, okay, so I'm in mainnet, I'm going to read the ladle address from mainnet and use it. Okay, I'm going to read the join from the environment. Here's what I do. I just put all the joins that I want to test in an array, and then I do a loop. And I just run forge test, passing that address as the environment variable. So here, I will say, okay, so this is the join environment variable. This is the join that we are harness testing, okay, with my real ladle and everything. And the important bit is that when you are doing the test harness, you should provide as little information as possible. Everything should be easily picked up from the chain. In this case, we are just getting the join address. We know the ladle address because we have it. And then from the join, we are getting the token. From the token, we are getting the unit. We are actually deploying a mock token because it doesn't matter which one it is. We could, and that's it. And we only grant permissions in this case because no one actually has permissions to retrieve on the joins. So we add them to the ladle to be able to test this. But in general, when you do a test harness, you don't grant permissions. You don't configure anything. You just read whatever is in there. And you pass as little information as possible and read everything from the network. Yeah.
Mm-hmm. Now, for something like the phi tokens or the pools, you would just update that array you have in the shell script every quarter.
Yeah. Whenever
Okay.
you want to include something in the test harness, you just include the address that says there. Cancel. I'm going to take this off. And when I want to run the harness on the joins, I just do the script, and it will run it on one join, this one, then on this other join, it's going fast, then on this other join, and this testing the same on each one of them. Okay. Now, the same that when we are setting up the harness, we are providing as little information as possible. When we are doing the tests, we are doing the same. We are trying not to set any hard-coded values if we can, or well, if we have to, we do. But in general, everything should be read from the network as much as possible. basically so that the tests of the test harness work. Because if you hard code the inputs and the results, it might not work for all possible scenarios because of liquidity or because of the stored balance in the join or because of whatever. So when you write the tests, you think a little bit in how to do each test in a way that it will work whatever the condition of the contract. It's not very difficult. You do it a few times and you really get used to the idea. It's things like, for example, this unit thing. So when you're doing unit tests, you might hard code the tests so that they work with 18 decimals and you test them with die. Okay, but then when you run that test in all the joins, and some are for USDC with 6 decimals and some are for WBTC with 8, it won't work because that will break. But if you just read the decimals from the actual token and store them into the unit and make all the tests relative to that unit, then the tests work for any set of decimals. When you actually do the harness and for one contract and then you run the harness in a different contract and it fails, you start seeing those things where you were fitting your tests too much to one specific contract instance, and then you just think how to generalize them so that they always work. It's fun, actually. Yeah.
Yeah, that's very clear.
Cool. Let me show you another little detail which doesn't exist in the join, but exists. This in this other one, the notional join harness, I included this modifier, only harness, because some tests will only work on the harness, some tests will work only on the mock, and you only have one test file for both. So basically, you are going to sometimes say this test, run it only on the harness. How do you do that? By adding the modifier that what it does is that, okay, if we are not in the harness, just return, don't run any of the asserts, don't do anything, return, and that will pass the test. You could put some console log or here, I think, and say this test not being run or whatever. I haven't done it yet. It would be a good idea. But yeah, the thing is that you can disable some tests if they don't make sense on the mock or if they don't make sense of the harness. That's how you do it. Yeah. So basically, since here I haven't merged the notional join harness and the notional join tests. So that's why the harness ones are all being skipped so that it doesn't send an error on CI. So it's a manual harness. You don't need to run the harness on CI. On CI, you only run the unit tests. Yeah.
Yeah, that makes sense.
Cool. Let me show you a last one, which is lots of fun. It's slightly different, the strategy V2 one. In this one is a little bit further on that idea of the modifier, where some things only run on the harness. Some contracts are mostly stateless, okay, and they have 1 or 2 states, and you don't really care what state they are on. The tests are going to run. Okay, the join is one of them. The join basically can be empty or it can have tokens, and that's about it. So all the tests are going to run. The strategies, on the other hand, they have a bunch of states, which I have them. Where's my state? Here. The strategies can be in any of these 5 states. And the unit tests work because basically they guide you through all the states and do the appropriate tests on each one. So when I have just deployed the contract, I run these tests, they pass, cool. Now I can move to invested. No, now I move to divested. I run the test, all good. Now I move to this state and so on. And the tests, unit tests move you through all the states happily. But in the strategy, in the real ones, first, you don't know in which state they're going to be when you start the test harness. Okay. And then you don't exactly know how they are going to move between states when you execute your setup functions. Because I could have a setup function that executes eject on invested, and then I do it in a very specific way so that it ends in ejected, or do it ends in divested or ends in trade, because that's the problem with this state. When you call eject on a strategy contract in the invested state, it can end in any of these three states. So you have that situation that you don't know when you're running your unit tests in which situation in which state your contract is in, and as you run the setup functions, you don't really know what is going to happen. How is it going to end? So I did the same in the strategy harness, in the sense that I have modifiers that say, okay, run this test only if you are in this state, and otherwise just let me know that you are skipping it, and then move on to the next one. And that way, whatever the state of the strategy, when you start the test harness will tell you what condition the strategy it is in, and then from that situation, it will test all that it can and tell you the things that it cannot test. The sense, okay, you have a strategy here, it's invested, all these things work. I'm going to test ejecting. Okay, when I test ejecting, it goes to this state, all these things work. When I move the time forward to maturity and divest, this is what happens. This is the state that it is in, and these are the unit tests that I can run. And that's just by the same idea of taking all the information from the chain and making it generic, like things like this. For example, how many strategy tokens am I going to mint? Okay, I'm going to mint a proportion of the total supply of the pool, because whatever is the liquidity, that's going to mint an appropriate amount to test this test. Blah 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 blah. Yeah, and then sometimes, as I said, I have some. Yeah, this test will only run if we are in the right state. Otherwise, it will be passed. This will run only if it's in the right state. And I think at the end, I only had to use them on those two specific ones. That's it. Okay. I know I talk fast. That's also why I record this. But that's everything that is behind the test harness. Okay, it's nothing crazy.
But that's also useful for checking, whether a series has matured, something like that.
Yeah, it can give you all that kind of data. When you run the test harness with all the addresses of all the FOI tokens, you will see the report at the end saying these ones have matured, these ones are not, and these tests are successful or skipped on each one. I'm wondering if there is some way of tricking Foundry so that here you could have pass, fail, or skip. That would be cool. I'm going to ask Georgios, I think. Well, I'm going to put it as an issue on the repo. All right. Any questions?
No, I understood all of that.
Awesome. Great. It was not that complicated. Okay, I'm going to stop the recording then. And this is ready for everyone to learn and play. It's fun. Actually, it was lots of fun.
All right, thank you for that. I'll work on the FI tokens today.
Cool. Awesome. Looking forward to see what you learn and say about that. Take care. Bye.
All right, goodbye.